Alright, so today we are going to finish up our last little section of 4.2. So this is day 2 of multiplying polynomials, and we're going to start with binomial expansion. So for a, b, and c, we're just going to find the product. And when we are doing this, I wanted to remind you that anytime we have an a plus b squared, this is not the same thing as a squared plus b squared. So whenever we have a plus b squared, this is not the same as a squared plus b squared. Alright. So now actually instead what we want to do is expand this out. So if we have a plus b squared, this is going to give us a plus b times a plus b. Okay, so whenever we have this, we want to use the distributive property in order to simplify. So we'll have a times a, which gives us a squared, plus a times b, which is a times b, or ab, plus b times a, which is ba, or b times a, plus b times b, which gives us b squared. All right, so now I want to simplify this a little bit further, and I notice that a squared can't be combined with anything else, so that's just going to be a squared. Okay, but then I'm looking at these next two terms. I have ab plus ba. And so whenever I'm combining like terms, I'm combining terms that have the same variable to the same degree. And both of those have the same variable to the same degree. They are in reverse order, but they are still the same thing. So I'm going to add those together. And since I have one of each, I will get 2ab. And so just up top in the corner here, I'm just going to write ab is the same as ba. Because 3 times 2 is the same as 2 times 3. So therefore they're the same. And then I'm just going to add on my last term here, which is just b squared. And that is our final product. Okay, so now let's try this next one together. I have a minus b squared. And just as a reminder, that again does not mean that it is equal to a squared minus b squared. But instead, we're going to expand that out. So we'll have a minus b times a minus b. And I'm going to use the distributive property here again in order to simplify. So when you do that, a times a squared, a times negative b, negative ab, negative b times a, negative ba, and then negative b times negative b gives you positive b squared. So now I'm going to simplify this again, and I notice that I have negative ab minus ba, and since those are the same variable to the same degree, I can combine them. So I have a squared minus 2ab plus b squared. And that is your final product. Alright, so go ahead and pause the video and try the next one on your own. Alright, so hopefully you pause the video and you notice that since you have a plus b times a plus b times a plus b, you've already done the product of a plus b times a plus b, which we did earlier in part A. So we can just write down that product as a squared plus 2ab plus b squared, and that entire thing times a plus b. Alright, so now we're going to multiply this through and use the distributive property one more time. And so a squared times a is going to give us a cubed. Then a squared times b is going to give us b squared b, plus 2ab times a is going to give us 2a squared b. So be very careful with that. We have 2ab times a is going to give us 2a squared b. And then we have 2ab times b, which is going to give us 2ab squared. And then we have b squared times a, so plus b squared a, and then b squared times b, which is going to give us b cubed. Alright, so now we're going to simplify this again just like we did before. And we have a cubed, and then now we're looking at for terms that have a to the second power and b to the first power. So these next two terms actually have a to the second power and b to the first power. So I'm going to combine those, and I have 3 of them total, so I'm going to add 3a squared b. And then now I'm looking for terms that have a to the first power and b to the second power. So these next 2 terms have a to the first power and b to the second power. So since I have 3 of them, I have plus 3ab squared, and then my last term, which is just b cubed. And that is our final product. So hopefully when we went through this, you notice that we also have a pattern kind of happening in our coefficients. So we have a coefficient of 1 in our first problem. We have 1, 2, 1. In our second problem, we have 1, negative 2, 1. And then in our third, we have 1, 3, 3, 1. So hopefully you're noticing some sort of pattern which will actually help us transition into Pascal's triangle. So Pascal's triangle, this is a really nice shortcut for binomial expansion. And so let's look at this second row here. So I'm looking at this second row, and I notice that I have a plus b squared, which is the product that we just did on the previous page. And Pascal's triangle gives us this binomial expansion. So if we're looking at Pascal's triangle, it's this triangle right here. And so we have in our second row, this is considered our 0 row. And then in this second row, we have 1, 2, 1. So if we look at the coefficients here, we have 1, 2, 1. So that's what Pascal's triangle does for us. It tells us our coefficients. So we should have coefficients of 1, 2, 1, which will follow the expansion 1a squared to the second, or a squared plus 2ab plus 1b squared. So we can use this instead of multiplying out by hand. Okay, so let's practice a couple. So I'm looking at the first one, and I want to use Pascal's triangle to expand x minus 2 to the second power. So since I'm to the second power, I'm going to look at the second row here. And so Pascal's triangle tells me that I should have coefficients 1, 2, and 1. So with those coefficients, I should get this. So I will get 1a squared plus 2ab plus 1b squared. Okay, now instead of just leaving it here, I have actual a values and actual b values. So I'm going to go ahead and substitute those values in and simplify my polynomial. Okay, so my a value here is going to be x, and then my b value is going to be negative 2. So when I write this in, I will get 1x to the second power plus 2x times negative 2 plus 1 times negative 2 to the second power. All right, so I just wanted to remind you, whenever we are substituting in values, make sure that if you have a negative number that you're putting it in parentheses, because that term is negative. So make sure that you keep the negative with the number. So let's simplify this even further. I have 1x to the second power. That's just going to be x squared. And then I have 2x times negative 2. And so I can actually rewrite this as 2 times negative 2 times x. And then for my next term, I have negative 2 to the second power. So if I'm putting this in my calculator, I'm remembering to put parentheses around the entire negative 2, and that will give me plus 4. All right, so I'm still not quite done yet, because I'm looking at this middle term here, and I have 2 times negative 2x. And I know that I can simplify that even further, because I know what negative 2 times 2 is. So that will give me x squared minus 4x plus 4. And that is our final product. So hopefully you're already seeing the value of Pascal's triangle, and maybe not when it's to the second power, but when it gets to the third power, it's extremely helpful. So let's do one with the third power. So we have 3y plus 1 to the third power. So I'm looking at this third row, And Pascal's triangle tells me that I have coefficients 1, 3, 3, and 1. So if you remember our problem that we did on the very first page, our third problem, we had coefficients 1, 3, 3, and 1. So here we're going to have the same thing. And so now we're going to follow this binomial expansion, and I'm actually going to change my color here so that we can see a little bit clearer what we're looking at. So in the table, it tells me that this should be my binomial expansion when I have something to the third power. Okay, so I should have 1a to the third plus 3a squared b plus 3ab squared plus 1b to the third. All right, so now I'm substituting in 3y for every a, and then a 1 for every b. Okay, so when I do that, I will get 1 times 3y to the third plus 3 times 3y to the second times 1 plus 3 times 3y times 1 to the second plus 1 times 1 to the third. All right, so now let's break this down a little bit further to simplify. If I have 1 times 3y to the third, I'm going to do the exponent first, and so whenever I have 3y to the third, I really have 3 to the third times y to the third. So let's just go through and simplify it that way to the rest of my terms. So the second term, I'm going to leave the 3 on the outside and evaluate the exponent. So this will give me 3 to the second times y to the second times 1 plus 3 times 3y. And then 1 to the second power is just going to give me 1. And then 1 times 1 to the third power is just going to give me 1. All right, so let's simplify this even further. 3 to the third power is going to give me 27y to the third plus 3 times 3 to the second is going to give me 9y to the second times 1. I don't need to write that every time because it's always times 1. And then moving on, we have 3 times 3y, which is going to give me 9y times 1, which I don't really need to write, and then I just have my plus 1 on the end. All right, so I can simplify this even further because I still have a multiplication problem right here. So I can simplify this further to be 27y to the third plus 3 times 9 is 27. So I have 27y to the second plus 9y plus 1. And that is our expanded binomial.